Hello students, welcome back to our ITC class. As we completed the fourth module, going to start the fifth one. So the fifth module name is convolution codes. As some basic you studied in the fourth module, that is the error control codes. In that it is classified into the two types, block codes and the convolution codes. So just we will give us some that is a little glance over that the block code, then we will study the convolution code. Look at here the block code, the diagram, the channel encoder I have taken k bit, that is input message in a block wise, and n bit code block output. Here for a channel encoder we are applying a block message, not bit by bit, and output also we are getting at the receiver side, it is a block wise, and the message will be split here at the output side, that is in the code block output as message k and check bits as n minus of k, or the check bits will be the first, message will be the second. It means in a block code the input will be in a block wise, output also we are getting in a block wise, and the output side first the message will be displayed, after that check bits, or the one more option is first check bits will be displayed then the message. So here what is the n and the k here is, n is a output, k is a message, that is bit. In a linear block code, or in general it is a block codes, it is represented by using a n comma k, and the output of this block code, it depends upon only the present input, not on the previous. For that, so it is represented by only the two, that is parameters n comma k. K indicates k, that is message bit, and n indicates, that is n bit of the code block output. So this is about the block codes or linear block code it is. Second one is convolution code. So actual in the fifth module we are going to study this convolution code. Look at the circuit here, convolution encoder, here k bit input and n bits output. So messages will be here taken as sequence bit by bit, and output also we are going to collect sequentially bit by bit here. In this, as compared to the block code, here inputs are sequentially entered and collected at the output side. Here in the convolution codes, the output not only depends upon the present inputs but also depends upon the previous inputs. Means it depends upon the two, present as well as the previous inputs. So to remember the previous input, the information or the data, we required a memory. So memory here we are using a flip flop. Why a flip flop? Because the flip flop stores the 1 bit data. That's what I can store the 0 or 1. So here how many notations are required? Here is n, k, along with that, so m is required. Means n is output, that is a n bit, k bit as a message, and the memory m. So we can represent the convolution codes by n, k, m. N, k, m it is. So togetherly this n, k, m pattern representation is called as the convolution codes. So what is the definition here? How we can going to define the convolution codes? Here convolution codes takes the inputs sequentially bit by bit and gives the output sequentially of bit by bit, and the output depends upon not only the present as well as the previous inputs. And always remember, in a block code n is greater than k, and here k is less than n. So here are the some notations required in the convolution codes. As we if the pattern is like this, so n, k, m used for a general n, k, m convolution codes. If n, k, m it observes in a question paper and all, so easily you can identify that it means it is a convolution codes. So what are the pattern, that is the notations are available in that. Just look at here. N is equal to, what N indicates? Number of output bits, as well as is also called number of modulo 2 adders. K is equal to number of input bits. M is equal to number of flip-flops, that is memory element. Capital L indicates number of bits in the message sequence. K by N ratio, we know the N comma K, that is the dimension. So when you wrote in the fashion of like this, K by N, so it will be a code rate or the rate efficiency. And constraint K is equal to M plus 1. Order of G matrix, that is L into N, L plus M bracket, that is closed by the big bracket. So capital L indicates the first one, it is a rows and the column. Already you know the G matrix. In order to generate the order of the matrix, means I should know, to write the generator matrix, I should know the first order of that generator matrix. So G indicates generator matrix. And the dimension of the code is N comma K. And N into L plus of M is equal to length of encoded sequence. You have to remember these notations. What is N, K, M, L, K by N, K is equal to M plus of 1, and how to find out the order of the G matrix. What is the formula of that? L into N, L plus M is the formula. So here are some definitions we wrote. What is the constant length? K is equal to M plus 1. It is very rare to ask the definitions here anyhow. So I have written here, you can go through with these definitions. That is, constant length is K is equal to M plus of 1. Code rate, the ratio of K by N is there. And dimension of the code, in the block code's dimension is N comma K. So what is the dimension of the convolution code? N comma K comma M, means N K M is the dimension of the convolution code. So dimension of the block code is N comma K here. Okay. As in the fourth module you people have studied, that is encoder circuit, syndrome circuit, correct? So encoder means you have to draw the circuit of that particular concept. Here also the same, convolution encoder means I have to draw the circuit of convolution encoder. There are two methods are available to find out the encoding of convolution. What are those? One is a time domain approach, second is transfer domain approach. Means encoding of convolution codes are classified or categorized into the two types. One is time domain and the transfer domain. In the time domain there are two approaches, again the two methods. One is convolution method, another one is generator matrix. Here time domain you can solve by the two methods, one convolution method or generator. Convolution method is somewhat complex compared to the generator matrix. And what is the reason why we should choose the generator matrix here to find the solution of the time domain here? In the fourth model we used the generator matrix to find the encoder and the syndrome circuit there. That's what we are choosing here in the time domain, generator matrix. Okay. So now we will consider one small example here for convolution encoder. Look at the problem will be like this. Consider a 212 convolution encoder. Find the output sequence for the input message 10011 using time domain approach. Second one is transfer domain approach. For G of 1 is equal to 111 and G of 2 is equal to 101 it is. Okay. So this is a given numerical I just read out. Now according to that you have to draw the circuit. This circuit is called as convolution encoder circuit. It is 212. So here I have labeled on that 212 it is NKM. So N is equal to how much? Number of outputs is equal to, that will be considered as modulo 2 adder. Just now I told here what is the N. N is equal to number of output bits as well as this is equal to the number of modulo 2 adder. So K is equal to 1. So what is a K? K is input, number of input bits. K is equal to, it will take the bit by bit. And M is equal to 2. What is the M? M is the number of flip-flops. So how many flip-flops are required? You have to take the 2 flip-flops first here. FF1, FF2 here. Then I used the G1, G2, G3, that is a 3 switch points. 3 switch points. So input is given here 1 0 0 1 1. I have taken input at the one side. Okay. So M indicate, that is a N indicates 2, means 2 outputs and 2 modulo adder. When I place the FF1 and the FF2, I have to place the top adder and the bottom adder. So 2 modulo adder, one at the top, another one is at the bottom here. So 2 modulo adder. Then TA indicates top adder, BA indicates bottom adder. Now look at the for, and in the he has given G of 1 is equal to 1 1 1, means this 1 1 1 you should do a connectivity to a top adder. Look at G1 I connected here, G2 switch point is connected, G3 switch point is connected. So that is a third shift for top adder, first adder. Then the bottom adder it is 1 0 1, means from this G1 is connected, but G2 is, we should not connect because it is a 0. 0 means I should not connect. Again from the G3, so bottom adder is connected. That is called generator sequence, or it is also called impulse response. So remember, G of 1 and G of 2 are nothing but generator sequence. Okay. Once you connected this, look at the from the top adder we are getting the output 1, and from the bottom adder it is output 2. So total how many output we are getting? 2 outputs. Look at here, N is equal to 2, number of output 2 and number of modulo 2 adder 2 it is. So here by the given numerical you have to draw the encoder circuit of the convolution. So this will give you a marks of 4 marks that generally it is going to ask, but he never say that you have to draw the diagram in a exam. So if the sentence is there, the numerical will be available, you have to read it and draw the circuit related to that. Okay. There are 2 approaches. He said find out the both. So first we will see the time domain approach by which method? There are 2 methods are there. There are 2 methods I told here. Look at here, convolution method and generator matrix. So here we are solving by using the matrix method, that is generator matrix. So given here it is N K M is equal to 2 1 2. So N is equal to 2, number of outputs, number of modulo 2 adder, K is equal to 1, number of inputs, and M is equal to 2, that is number of flip flops. L is equal to 5. What is the L? The sequence is given that the input 1 0 0 1 1. So how many bits are there in a given input? D is equal to, there are 5 bits. So L is equal to 5, that is number of bits in the message sequence. Then the impulse response or the generator sequence is given. How? G of 1 is given, that is 1 1 1, splitted it is G of 1 1, G of 2 2, it is a top adder generator sequence, and G of 2 is 1 0 1, so it is a bottom adder generator sequence. Okay, this much is done. After this you have to find out the what will be the order of the generator matrix. To find the order of the generator matrix, what is the formula? L into N L plus M. So L is 5 into N is equal to 2, 5 plus 2, 5 plus 2 is 7, 7 into 2 14. So 5 rows and 14 columns. Now you have to generate a matrix. Okay. So 5 rows. So G1, so top adder generator sequence is 1 1 and bottom adder generator sequence is 1 0 1. So you have to make it as 14 columns 5 rows by considering 2 bits of the combination. Why? Because 2 generator sequence are available for top adder 1 and the top adder and the bottom adder. So to multiply here, top adder of 1 and the bottom adder of 1, so it will be 1 1, you have to write it in a matrix. Then 1 0 1 1. If you wrote like this, so it will become 6 rows, 1 1 1 0 1 1. Total how many? That is, it will become the 6 columns. How many columns you needed here? 14 columns. 14 minus of 6. You need another 8 columns. So remaining columns you should take it as 0 0 0 0 0 0 0 0. Okay. So, this will be a completed that is a column we just created it. There is a first row. First row, what are the elements you got? 1 1, multiply here, top adder, bottom adder, 1 1, 1 0, 1 1, so like that. Now, after this you have to shift it is. Shift a 1 1 bit right side. So, the first I shifted here, that 1 1 it will go to the next one. So, 0 0 1 1 1 0 1 1 0 0 0 0 0 second row. Third row, just you have to shift the one bit to the right side. Fourth you have to shift one more bit like this. The fifth bit when you shifted, no, so it will give you correctly 5 rows and the 14 columns. See the order of the matrix. Once the generator matrix is developed, then you have to find out C is equal to D into G here. So, C is equal to 1 0 0 1 and 1 1, multiply here. So, we will get the result C is equal to 1 1 1 0 1 1 1 1 0 1 0 1 1 1. So, this is about the generator, that is a C is equal to code vector by using the time domain approach. Next is transfer domain approach. So, result will be same it is. So, D is equal to 1 0 0 1 1, we converted into the polynomial of the input. Dx is equal to 1 plus x cube plus x4, you know how to convert this. And g of 1 1 1 1 are taken in the polynomial 1 plus x square, and g2 1 0 1 in terms of g2 of x is equal to 1 plus x square. So, now you have to find out the top adder output, because the two outputs, no. So, top adder output, that is a 1, c1 of x is equal to, what is the formula? Dx into g1 of x. That converted you can put it here, then multiply. So, we will get c1 of x is equal to 1 plus x square plus x cube plus x raised to 6. Bottom adder, so to formula is c2 of x dx into g2 of x. So, multiply here, you will get c2 of x is equal to 1 plus x square x raised to 3 x raised to 4 x raised to 5 x raised to 6. Now, you have to combine these two to get the final output of that. So, general equation is c of x is equal to c of 0 x raised to n x into c of 2 x raised to n, like that up to the n minus of 1 term. When you substitute in this, c of x is equal to c1 of x square plus x into c2 of x square, because n is equal to 2 here. So, now c1 of x, what is the value? 1 plus x square plus x cube plus x6, that you have to substitute here. So, it will be a square plus x into c2 of x square is there. You have to take the whole square of that c2 of x. So, now take a square. So, 1 into 2 1, x raised to power of 1 into 2, you have to multiply here, 2 4 6 12 it is, means 2 into 1 2, x raised to 2 into 2 4, x raised to 3 into 2 6, x raised to 6 into 2 12, plus x, again the same thing you have to multiply, that is take a square, multiply with respect to x. After that, so you have to arrange the whole polynomial in a one sequence. So, c of x is equal to, it will be a 1 plus x raised to 2 4 x raised to 5 x raised to 6 x raised to 7 8 is not there, 9 11 12 13 it is. Okay. Now, you know how to convert this polynomial code to the binary. So, why I am taken the 2 bit? Because the 2 modulo adder are there, and the generator sequence also the 2 here. So, 2 bit we will get. Just look at the answer here. The above output answer of this transfer domain as well as the time domain answer is same here. So, what we understood is, so answer will be same, but the methods are different. In the same way, what I solve the problem, no, the same you have to solve the, take this one as a homework. Consider a 2 1 3 convolution encoder. Find the output sequence for the output message. D is equal to 1 0 1 1 1 using the time domain and the transfer domain approach. For given g of 1 is equal to 1 0 1 1 and g2 of 1 1 1 1. So, you should consider this as a homework. Okay. Thank you, students.